mass by dividing the mass with the number of moles. Yes? So this equation can be seen in two different forms like this. It's a very important equation, always remember. And then there is another one which is really important. And that has to do with the Avogadro's number of particles. So remember always that the number of moles also, like there, is equal to the number of particles, whatever it is. Formula units, atoms, molecules, who cares? Number of particles divided by Avogadro's number, which is what? Particles per mole. Particles go the way, the mole here goes on the top, and you have a number of moles. So this one, that one, and that one, they are very important equations to remember. Very important. Either one of them. You just remember one and the other two are derived, right? Then, there is another one which is really important. And we'll see that when we talk about gases, but it's a good thing to review things because some of you already know this. The number of moles, again, of a substance, which is gaseous. Gases, we're not talking about solid or liquid, it has to be gas. The number of moles is equal to what? The volume of that substance, the gaseous substance, can be chemical compound or element, who cares? It's a gaseous substance. The volume of it divided by the molar volume, if the two volumes have been measured at the same temperature and pressure. If that's not the case, this equation is no value. So be sure that you remember that. The two volumes have to be measured at the same temperature and pressure. We'll know why later it has to be that way. Again, two equations more from that one. Oops, where are you? Josh, why don't you stop me?
Oh, yeah. I'm good to go.
Huh?
I'm good to go.
Okay. I didn't see you coming in. I didn't see it. You see? The mind is somewhere else. The eyes are very poor. The eyes have no power. The mind has the power. Okay, so we're going to see a boom between hydrogen and oxygen.
Oh, it's going to be the really long thing, huh?
So one of them is only hydrogen. The orange is only hydrogen. The other one has hydrogen and oxygen in a stoichiometric ratio, is it? 1 to 2, just like the equation is balanced, 1 to 2. One volume of oxygen and 2 volumes of hydrogen. Stoichiometric ratio, hydrogen and oxygen. The purple. The orange is only hydrogen. Try to notice which one is going to have more boom. And then to understand why. I want an answer why that one has more noise than the other one, okay? So let's do both and see which one is louder, and then we'll figure out why it's more louder, right?
Can you think of a louder band? Yeah, but doesn't oxygen also help
Plug your
fire?
ears.
I'm so scared, man.
It's gonna...
It's okay, Michael. I hate these.
Oh, that's so sick.
Send me this video.
Send me the video after.
Okay.
No, since I want it, it must be better.
Dude.
Okay, which one was louder?
Orange.
Hydrogen and oxygen together, or the one that has just hydrogen? The one that was a mixture of hydrogen and oxygen, right?
Yes.
It was much more loud. Why? Why is that? Huh? No, in both, water was forming in both. That's not the answer. Why? Both form water, so that's not the answer. Why, when hydrogen and oxygen in the same balloon, more boom than when it's only hydrogen in the balloon? Why it's more...
That's pretty skilled.
Because in the one was there's hydrogen and oxygen. There's since there's also more oxygen is going to form bonds with the hydrogen during the reaction.
In both cases, bonds form. That's not the answer. Try more. Come on. Why?
It's a long video.
What do you add?
Hydrogen is more flammable than oxygen, and when the flame was exposed to the hydrogen, it burnt up, and that made less noise than the one that the hydrogen, the oxygen. The oxygen didn't necessarily burn up, so it was like released.
Okay, one more try. One more try.
In the orange balloon, there's only hydrogen in there, so there's less particles than the one with the pink balloon, which has hydrogen and oxygen, so there's more particles to react with, so they collide more often.
Tell me the answer.
One more time. How do you want to go? How many people go?
Give it to Heather.
Oh, okay.
Give it to the
maybe
TA.
It's because the oxygen and the hydrogen in a 1-to-1 ratio, they react with each other, and with the addition of the energy from the flame in such a way that it releases more sound energy.
That's close to. There is a component there that is pretty close to reality. Okay, so let's take it this way, okay? Just two or three more minutes. It's a cool answer, okay? Just listen. What is noise? That boom, what is it? Energy. Somebody said energy. So, when you had a big boom, you got more energy. Yes?
Yeah.
Let's assume we have started with the same amount of hydrogen. And all of it reacted, because this reaction is quantitative actually, if you don't know what it is. I mean, all of the hydrogen will react with oxygen to give you more. So if we assume we have the same amount of hydrogen, it will pick up oxygen from the air or from within the balloon and give you the same amount of water, because we assume we start the same amount of hydrogen. The energy that will be produced, if you start with the same amount of hydrogen, will be the same or not? You start with the same quantity of hydrogen, produce the same amount of water, will get the same energy or not the same energy when the reaction is done? Same. So one time you get bigger boom, that means more energy than the other one. Is that true? Or I'm doing some mistake here?
It's true. True. True that.
Valid.
You get the same energy. But you get more boom, that's more energy, and the other time less energy. What's going on here? It's a paradox. What am I doing wrong? I'm thinking, why it's wrong? Why there is such a discrepancy? Why?
The reaction with the oxygen is happening faster.
Kinetics.
Kinetics.
Both times the energy released is exactly the same. When you hear the more boom, the energy is released in a much shorter time than the other case. In the other case, it's released but slower. It takes more time to be released. The other time, it happens instantly. All the energy is released at the same time, so you hear a bigger boom. Why? In one case, the energy is released suddenly, hydrogen and oxygen together in the same balloon, and the other time we have only hydrogen in the balloon, is released slower. It takes more time to be released. Why? She says because oxygen is outside of the balloon. Interesting. The oxygen, in the case of just hydrogen in the balloon, is outside of the balloon. And the hydrogen molecules, the poor things, are trying to find out oxygen molecules to react with. In the case that they're together in the same balloon, they don't have to look around and find oxygen molecules, which is only 20% by volume in the air. Most of the collisions will be between hydrogen and nitrogen molecules. Until they find oxygen, it takes time. But when you have hydrogen and oxygen in the same balloon, the hydrogen molecules immediately are in contact with oxygen molecules, yes? And when the reaction starts, immediately they say, we got it. Boom. How many people understood the explanation? Raise your hands. Pretty cool, huh? Okay.